All right, a few folks are drifting in, but we will talk about getting started as it's time. Thank you all for coming to the last session of the conference. I'm always grateful when people show up for the last session rather than just deciding I'm done, my brain is full, I'm going home, I can't take any more. So I completely appreciate that. So we're going to talk about microservices, and particularly we're going to talk about why has there been a backlash against microservices recently? Why has this great hope for software development become a little tarnished in people's views in recent years? Those of you that know my talk, TDD, Where Did It All Go Wrong? It's in a similar context. So famously, some of you may be old enough to remember, there was a footballer called George Best, an Irish footballer, and it was the first real celebrity footballer. And there's a famous story from his autobiography where he is lying in a hotel room with a couple of supermodels, discarded bottles of champagne, lines of cocaine lying around, the bellboys pushing in the cart with the lobster or whatever, and he looks over at the bed and he goes, George, where did it all go wrong? And so it's said in that context, right? I don't think microservices itself are necessarily wrong, but I think that we have made some poor decisions about how we've approached microservices. All right, I can't get this to work. That'll be all right. We'll move to this. All right. Who am I? They're just long and difficult to read, and it just says that I'm old, right? And that's really all you need to worry about. Any .NET devs in the room? You. So I work on an open source project called Brighter. Mass transit and Mediator are going to commercial. We provide an alternative to both of those. We predate Mediator. We predate mass transit as a framework rather than a broker. So we've been around for a long time. We are I like to think of us with a velvet underground of basically messaging frameworks. All the messaging frameworks you know about have stolen ideas from us, but you don't know that we exist. All right. Even DAFA stole ideas from us. Okay. What are we going to talk about? So fundamental definitions. I think one of the most important things that's gone wrong with microservices is we haven't all understood and used the same vocabulary. So we'll start by having a talk about the vocabulary, and we'll talk about why some misunderstandings have crept in there. That'll lead us a little bit onto the problem space. What does it look like when things go wrong with microservices? And then we'll get into some advice. What could you actually do to try and stop getting into this space? All right. So let's talk about some definitions of words. The first thing, maybe just because it is Thursday afternoon, there is, of course, as all of you know, a fundamental theory of software engineering, which was defined by Edward Yourdon and Larry Constantine in 1975. Anyone remember what the fundamental theory is? Should be on the tips of all your tongues? No? It is Thursday afternoon, so what we'll do is we'll give you a quick reminder, and I'm sure you're now all a lot wiser as to where software engineering goes. So, just in case you're a bit tired and you want a bit of a reminder, this is the fundamental theory of software engineering, which is that due to complexity, it is always easier and cheaper to create two small pieces rather than one big piece if the two small pieces do the same job as the single piece. This is because combining two problems in one piece forces us to deal with the unneeded interactions between the two pieces. What does that mean? So I work for what you guys call Menulog. We brand locally, but if you can imagine, we have some code that deals with the shopping basket that you put your purchases in, and we've got some code that deals with how we assign your goods to a given courier to bring to your house. Those are quite separate things. If I shove them all together in one code base, that's obviously going to get a little bit complicated and difficult to deal with, more so than if I just treat them as two separate things. Right? And this principle was effectively defined back in 75 as being one of the fundamental things we needed to understand. And specifically, we suggest that the cost of implementing a computer system will be minimized when the parts of the problem are solvable separately, which is the kind of idea we defined. These are two things that don't bear any relation to each other, and therefore, essentially, you can independently think about them. And manageably small. And back in 1975, there was another bit of advice here, which was everyone has a different definition of manageably small, which is one of the problems, right? What do we mean by manageably small? All right, so let's define some other things. What's a module, okay? So technically, a module is a lexically contiguous sequence of program statements bounded by boundary elements having an aggregate identifier. I have no idea what that means either. But another way of saying it is a module is a bounded, contiguous group of statements having a single name by which it can be referred to as a unit. That's a bit closer. So generally, a module just means a named collection of code, right? We have some code. We decide that code relates to each other. We give it a name, and we give it some kind of packaging mechanism, right? In theory, a class is a form of module, but typically we usually mean slightly more than a class, some sort of code. So if you're in something like Python, it's very explicit, you have modules. If you have something like .NET, assembly is the closest thing we actually have to a modular language. All right, so what's a component? So a software component is something that's independently replaceable and upgradable. And there are two main types of component: libraries and services. So we'll park services for a second, but by libraries we kind of mean the things that you get from NuGet or npm, or that you essentially build and distribute yourselves locally, right? So libraries are a unit of effectively reuse, and essentially they are a module, right? Just a reusable module, but you package it in a certain format that your given programming stack understands. So components break to modules, but they're replaceable. In other words, whatever is in my module, I could upgrade and change the implementation details, and you would, as the consumer, be able to take that upgrade without breaking stuff, right? So we do that every day, right? So you go to NuGet, download a new version. If it hasn't got basically a major version increment, you assume it probably works. So you can replace an upgrade without really showing too much concern about it. So that's an idea we're pretty familiar with, and it works pretty well. Okay. So a service is a component that exists in its own process. So rather than a library which runs as part of whatever process you are building, a service is a separate process. Because it's a separate process, we have to have some kind of interop between the two processes. So we'll use something like RPC, RESTful calls over HTTP, messaging to communicate between the two of them, right? But a service is ultimately, it's a module, and in fact a component, where what we've chosen, so it's a replaceable module, where rather than effectively working in process with you, it runs externally and out of process. All right. So for a service to be component, the key idea is it must be upgradable or replaceable without impacting the other service. Okay. So microservices, the typical definition of them is they are a set of practices for successfully building a software component architecture style at scale. So, the key idea of microservices is componentization via services. Right? What do we mean by that? Well, we mean essentially that we are going to break the problem down into a series of processes that interoperate with each other. All right? So that is the key idea that we just discussed, componentization via services. Yep, okay, works. They are organized around business capabilities. What do I mean by that? Well, when we think about what are the boundaries we're going to set for these services, how are we going to pick how this unit of code with a name and this unit of code with a name, how do we slice things up? we're going to use business capabilities. So that just we mean basically a given function that the business delivers. Smart endpoints and dumb points less useful to us here, but we already were saying the intelligence or application lives in the services, not in the plumbing. Designed for failure. Because we're running our system now as multiple independent things, we don't want to basically risk that one of those things going down brings the whole system down. So we design for the failure of individual components. If they're HTTP, basically for interop, we're probably going to use some kind of proxy and have multiple instances of them. If they're basically messaging, we're going to rely on messaging itself to give us basically that resilience. We're going to have to probably invest in infrastructure automation, because once we now have many things to deploy, it's probably going to become too complicated to do it manually. We're going to have to invest in decentralized data management, because each one of these services is going to own its own data. And it's not that, if it's operational data that it owns is effectively belongs to it and you can't reach it apart from an API, we have to figure out, well, how we're going to do things like reporting, etc. So we need some kind of data lake or a data mesh to solve that problem. We have to decentralize our governance, because now our data lives everywhere. And we have to start thinking about products, not projects. And what we mean by that is teams clustered around a service that offers a business capability, working very independently of each other. And that's what microservices is supposed to be. Right? Okay. And they come with some benefits. So the module boundaries are strong, and that's why you move towards a model which has module boundaries based on a service model, in other words, processes, because it's very hard for a developer to go, oh yeah, just this once product, what I'll do is I'll reach in to the other bit of code and I will get the value directly, right? That's a big ball of mud happens. So one of the problems in Monolith is what we call big ball of mud. Big ball of mud happens because our module boundaries break down. Why do our module boundaries break down? Because it becomes really easy to take a shortcut when product tells you that it needs to be out by the end of the week, right? And so the strong module boundaries, because they make it hard to do that, actually prevent the breakdown into a big ball of mud. Independent deployment, so there's no release trains. My team can basically decide, okay, we've got a few commits in that are worth releasing, we can dump a release. And because we are independently replaceable and upgradable, nobody else has to worry that we've done that. Technology diversity, again, less the focus of this conversation, but it means, if I've got multiple services, they can all be built in their own stack. Fault tolerant, well, we discussed earlier that by breaking things up, we need to basically build them in a resilient way. But because they are independent, it means a failure over here doesn't bring down everything, right? I can manage the failure of that thing, perhaps. I'm not bringing down the whole monolith every time things go down. And perhaps most importantly, in terms of what microservices was really for, cognitive load is much lower, which is really this idea we had originally from Jordan and Constantine, that it's easier to solve these problems as manageably small and solvable separately, right? Cognitive load just refers to this idea of how much stuff can I shove in my brain. So it's more simply put, code that fits in my head. I want to deal with code that I can reason about and fits in my head. All right. It has some costs, right? So one of its costs is distribution. Distribution makes things more expensive, because as soon as I make a call to a function, if it lives in a different process, then essentially I'm now exposed to all the ways that could fail. So it's more costly to do. I may also have to create many more build scripts, many more observability implementations, lots of more problems with how I manage my data now it's decentralized. So there's a cost to distribution. Okay. Verification can become a little harder. People, when they first start using microservices, are kind of like, but how do I know that it all works? I better write tons of end-to-end tests that go across everything I own. Well, these are really expensive and brittle. What's gone wrong, right? Operational complexity, I now have many more things to deploy. And skill issues. People may not be distributed systems developers. So you may be asked them to do something that's completely outside their experience, and therefore they will probably run into issues. Okay, look at that data a bit. And so this is what's referred to as the microservice premium. Right. You shouldn't be doing microservices unless you're solving big problems. If you're a team of 3 people and you go, what we need is microservices, probably the answer is you don't. Right. So what triggers the need for microservices? So one of them is code that doesn't fit in your head. Right. You can solve the problem, though, of code that doesn't fit in your head with modules. So if there's not a lot of you and you feel okay about not violating the boundaries that basically are in process, you may be okay with modules. At least the 5 pizza teams. So this pizza team idea is supposed to be a little bit vague and elastic. It comes out of Amazon. So these are big American pizzas. I can't remember what the size of the pizzas are like in Australia, but you know how Americans have these huge boxes of pizzas. So a 5 pizza team is probably about 20 people, right? Once you get beyond about 20 people, etc., you start to get into the realms of you get enough teams that it becomes a little more difficult to coordinate releases and everything else that's going on. So you might break things up. You should understand your subdomains, right? So you have to have some idea of what the subdomains are that you want to break the microservices out into. You have to have a feel for that. And those subdomains need different forces for change. In other words, need to be solvable separately. Right? And typically, we're also looking for a wide range of interactions. So often, you have very different ways, different clients, exposed in different directions of getting hold of this data. Another way of expressing that is this. Right? Okay. All right. So why have things gone wrong a little bit with microservices? What's caused a little bit of a backlash against this idea? So the first problem is really this word micro. All right. So here are some previous quotes, right? They are very, very small. I mean, 100 lines of code is probably a big service these days. That's said by Fred George. It's more than one programmer to develop and design and maintain. It's not a microservice, Fred says, offered. A single function microservice provides us with the highest degree of granularity. This increasing granularity gives us more control over an application's resource consumption, availability, and scalability. And indeed, once upon a time, the precursor name to microservice was fine-grained SOA. So SOA was the previous generation of thinking about services, service-oriented architecture. Probably over-associated potentially with SOAP. But the idea is it's fine. Netflix called it fine-grained SOA. This idea it was much smaller components. And the problem with this focus on size is that often these things were not doing significant amounts of work. And we're seeing a little bit that just adds to the complexity rather than takes away from it. And what micro really refers to here is the notion of replaceability, not the notion of size. What we want is something that's effectively replaceable. In other words, I could conceive of being able to rewrite this and swap it out with something else, right? But size per se, 100 lines of code, etc., is not what we're after in terms of what the word micro means. We'll come back to that. So this, anyone seen one of these? This is what we call a Death Star diagram. All right. So this one, I believe, is Twitter, or old Twitter. It's Twitter as opposed to X, right? Monzo famously tweeted one, which Monzo were kind of like, look at the complexity we manage very proudly, and the rest of us are going like, oh my God, what have you done? We drew up one of these at my current place. So a lot of this talk was inspired by problems we faced. Yeah, we broke several tools in trying to basically get it to happen. So typically when you have these Death Star diagrams, just to give you some feel of scale, the numbers you're talking about are 500, 1,000, 2,000 services. As you can imagine, that's a lot, right? And nanoservices is the generic name we give to this as an anti-pattern. I know some people try to use nanoservices as a positive statement, but nanoservices is always an anti-pattern, right? And what's the problem? You have a lot of integration points. Any integration point, because it's basically between two individual processes, is a potential point of failure. So if I have 500 nanoservices, I've got 500 points of failure. If I have 2,000, I have 2,000 potential points of failure. High latency. So there's a problem that's typically referred to as a federated query. And what happens is somebody at the outside, the user, wants to get some information and they do a get. And that get, the way you're actually going to service that is by farming that get out to, say, 2 or 3 other components that you need to get information from. And they in turn do 2 or 3 other components. And they in turn do 2 or 3 other components. And before you know it, you have really long call chains. So Twitter famously, to render its timeline, was 64 individual calls. And that leads to significant latency costs. They have a high operational overhead because every single service is going to come with its own needs for build scripts, telemetry, secrets, hosting on containers or landers, or whatever your weapon of choice is, right? And that's a significant basic level of complexity. If you've got 2,000 deployables, that's a lot to cope with. Synchronous orientation. So typically, when you get towards about 2,000 services, most people, what they've done is they took some monolith and they broke it along function call lines and sort of made every class inside practically a service, right? And the problem with that is it's very synchronously oriented, and synchronous orientation is less resilient, particularly if you've got long call chains. What you end up with is actually very low cohesion and high coupling, which is weird because effectively you think perhaps, hey, my reason for breaking this up was to basically decouple everything. But actually, typically your problem is that you have massive coupling because the things are too small, and essentially they couple to huge numbers of other dependencies around you, other services. And you, weirdly also, the other problem you were trying to solve, which is basically to improve your release cycles from a monolith, you typically end up with long release cycles because you have to coordinate essentially across huge numbers of services and changes. And what you also get here is basically, oops, sorry, go back. Shotgun surgery. So in order to change something from a simple business requirement, you have to hit a large number of actual services. So we had a sort of internal sort of mantra at this about like 28 teams to do X, right? This notion that a simple business problem, well, you know, even with any microservices, you might have hoped there's probably 3 or 4 or 5, whatever. It was 28, 30 was the number we were getting. So order of magnitude difference. And that requires coordination across all those teams, coordination across all those project managers, and it's a nightmare, right? So the problem is this, right? So what happens when we think about services is that as we increase the number of our components, the amount of code in each component reduces, right? That's the goal we were talking about right at the beginning with the ordinal constant time, right? And that decreases what we call intramodule effects from coupling. So in other words, the code coupled to other code inside the module can cause me issues of when I'm trying to change something. Obviously, as I have less lines of code, less intramodule dependencies. So as you begin to break something up into microservices, at first, all seems great, right? Yeah, I don't have any problems anymore with dependency on X, Y, and Z. But what's rising at the same time is intermodule dependencies. In other words, the cost of your module talking to other modules. And at a certain point, your problem will become that the cost of your intermodule dependencies now begins to exceed the benefit you're getting from your reduction in intramodule dependencies, and the costs go back up. So there's a sweet spot somewhere in the bottom, in the middle of this graph, where effectively we're balancing the number of components we have with the size of the individual components. The problem is, it's difficult to say there's a mathematical formula that will give you that. All right. It's a lot of trial and error, it's a lot of figuring it out. But certainly if you have 500 things, you're probably on the wrong side of it. If you have 50 things, perhaps you might be on the right side of it, depending on what your domain is. Right. And that is where we've gone wrong. Too many people have effectively ended up crossing that curve, and what they have is now huge cost because of microservices. And that's why they go, we should go back to a monolith, right? And the monolith has its own set of problems. They haven't gone away like big ball of mud. Those are still going to haunt them. It's just that effectively they're so desperate from where they are, they can't see what the problem happened. So why do we get here? So I love team topology. Everyone read team topologies? If you haven't read it, I can guarantee your management chain is reading it by some point. It's a really good book, and it's a book about essentially how we organize teams. So it's kind of socio-technical aspect of basically software architecture. One of my only problems with the book is it doesn't have enough anti-patterns in it, right? It doesn't tell you about why things go wrong. So one of the patterns I see that leads to this nanoservices is what I call fracture plane team availability. So in team topologies, they talk about breaking things up into teams and that relevant code that they own. And it talks about a fracture plane being a place that allows the system to be split in two or more parts. What I see a lot of is fracture by team availability. In other words, what happens is we have a piece of work to do, and clearly it belongs to this service. The team with that service has got a backlog that's as long as your arm and are very busy, and they say, we can't get to it for 6 months. So someone says, great, well, we'll just write another service. We'll write another service and we'll just interrupt between the two, right? And when that process goes through again and again and again, you're doing it, it feels at first like, this is great, we're solving problems. We've solved this problem of dependency on that team's availability. We've just written new service over here, right? But some of these services are just so pointless as to be redundant. So one we have a service called restaurant hours, right? Literally it's an API, and it takes in and records the hours that the restaurant is open. It does nothing else, right? There's another service called availability, which figures out from the hours when the restaurant's actually open and a whole other factors. Restaurant hours is entirely useless, but and it should have just been an API on the other service. And the reason it exists was because that team wasn't available, the availability team wasn't available, ironically. And the hours service, therefore, essentially ends up just as this kind of vestigial thing because another team was available and they could write it, right? And that is, the road to hell is paved with that particular route because things just increase and increase and increase. The problem is that everyone forgets this important rule, right? Which is the cost of ownership exceeds the cost of authorship. So if it takes you 3 months to write some software and you own it for 36 months, it's an order of magnitude more cost to own it than it was to write it. So optimizing for authoring software can drive you bankrupt because you could write software faster than you could actually pay the cost of maintaining it. And you'll end up going, oh my gosh, our business is going under because we've written too much software. Right? So you have to reduce the cost of authorship because ultimately that actually improves the time to market, right? Because you need to basically think about how, I don't want to have 26 teams to do X in the future. Okay. The other slight problem is services. I know I've already had a go at micro, so what's wrong with services? So we said earlier basically that the service model used componentization by services, which means by processes, right? We use the process boundary to break things up. The problem is that what happened was people began to understand that as a service is a single process, right? And so you get this idea of each service is autonomous and self-contained and runs as a unique process, right? Which is not what was said. That developed into a microservice is basically a container. Each microservice is packaged as a Docker container to enable deployment to a Kubernetes cluster for application orchestration. A cloud-native application consists of discrete, reusable components that are known as microservices that are packaged in containers. And I used to meet DevOps people who would say, oh no, the DevOps community created microservices and it's just containers. And I'm like, there's so much history lost here in the space of a few years. It was created by James Lewis and Martin Fowler, and it had nothing to do with containers, right? But that became the prevalent idea that a microservice is something running in a container, right? And also Lambda. right? So it isn't that lambdas are any better. Microservices also became something running in a lambda, right? Does anyone see this story? It's taken down now, so you can't see it. Yeah, James remembers. So Prime Video, AWS Prime Video is actually in London, and they wrote a blog post, and it was called From Distributed Microservices to Monolithic Application. The title was a bit of a problem. And what they described was they essentially they were doing some processing of video that got uploaded, and effectively they did it all by step functions in AWS. Those of you that don't know step functions, I can't remember what the Azure equivalent is. Anyone remember what the Azure equivalent of step functions is? It's when you do some orchestration across multiple lambdas, basically. And so they had this thing, and it was a little bit complicated. I'm making the whole thing jiggle, and that's not good. And what they did was they said, actually, we don't need all these multiple step functions. We could just actually have the logic and make it run inside a single process. Right? So they just said, so a step function is basically an external orchestrator, and they said we don't need an external orchestrator, we probably need an if statement, right? So they put it in a single process with an if statement, and the whole thing ran a lot better. The trouble is, because of the headline and the way that they described it, everyone basically decided that this was the perfect evidence they needed to decry microservices and say, even Amazon can't make sense of serverless on microservices. This is our favorite man, DHH, creator of Ruby on Rails. This really sums up so much of the microservices craze that was tearing through the tech industry for a while in theory. Now the real world results of all this theory are finally in, and it's clear that in practice, microservices pose perhaps the biggest siren song for needlessly complicating your service, and serverless only makes it worse. I think the man has a few things he wants to get off his chest. Of course, there's nothing to do with that, right? It's actually far more to do with how do you scale something, how many processes do you break it into, and we'll come back to that later. Right? But hey, you know, microservices are tough, right? All right, so what advice can we give you to try and solve this problem? So I don't know, Chris is in the room. Is he Chris Simon in the room? No, okay, Chris is around. So I was actually coming back from NDC Porto, and I was talking about this problem. I didn't really have a framing context for how to describe the advice. And Chris had given a talk. There's a link there. The slides are on GitHub, my GitHub. Experiences scaling a modular monolith to microservices using the 4+1 views. So he explained to me that he talked through 4+1 views, and it's actually really useful when you begin to talk about microservices to kind of explain the problem space. So I stole this particular framing device from him. Thanks, Chris. So for those that don't know, a guy called Philip, I don't know how to pronounce his name, Cruton. Anyway, he basically looked at the way that when we do software architecture, we model things, and lots of different models and variations. And he said, actually, all of these models are useful, but they're representing different views of the system. And there is no universal model that represents the whole way we think about software when we're building it. And he identified that there are 4+1 models we need to think about. The +1 is the scenarios in the middle. So there's a logical view, and that's essentially when we think about the domain that we are engaged with. There's a development view when we think about slicing that up into modules, classes, those kind of ideas, right? So that's really where we think about the code that we're writing. The process view, when we think about, okay, how are we going to basically make a scalable application? How many pieces do we need to divide it into, right? Are we going to separate our web app from our worker process that reads messages? That's the process view. And the physical view is, how do I put those processes, how do I deploy them out to production environments? And part of the problem is when we think about microservices, we have kind of applied them in places where they're not appropriate. Right? They really belong to the development view and not many of the others. Okay. So we'll cover scenarios briefly just so you get the whole picture. Elements in the 4 views are shown to work together seamlessly by the use of a small set of important scenarios, instances of more general use cases. So use cases are a slightly older technology for describing requirements, and you can pretty much replace them with things like user stories as a driver to discover the architectural elements during the architecture design, as we will describe later. So it's how we capture requirements. So there's the functional requirements. I quite like a technique called domain storytelling. If you don't know what domain storytelling is, it's really good. I haven't got time to go into it, but what you do in domain storytelling is you think about actors and work objects. So an actor's either a system or a person that wants to achieve something, to think that whatever you're modeling as a business problem, and the work objects are the things they interact with to do that. So if I'm buying a ticket, I as an actor am a kind of ticket buyer who is interacting with a teller to basically buy my tickets from, etc. Right? And that they may be interacting with a seating plan, etc. So you can map the whole thing that way, and it's a really good way of understanding the domain, and it's technology free if you want to. It's called pure model, so it works really well when you're talking with people like product managers and end users, because it's all very visual. It's a really good tool. We also need to think about non-functional requirements. Nowadays we tend to call them quality attributes rather than non-functional requirements, so they're desirable properties of the system. There's a model called attribute-driven design, and what that really means is you evaluate various candidate attributes like maintainability, usability, security, testability, and you write down what you need for each one of those. And so the idea of that is, given the domain problem, there might be n possible solutions. How do I choose which solutions are appropriate? Generally, it's the ones that meet my non-functional requirements, my quality attributes, because they're the things that say this rather than this. So as an example, if I have 10 people using my system, or I have 10 million people using my system, those are very different quality attributes I want from the system, right? And they will inform my design-making process and decision. All right. So, logical. So the logical architecture primarily supports the functional requirements, what the system should provide in terms of services to its users. The system is decomposed into a set of key abstractions taken from the problem domain. So it's how we explore the requirements. We may build a domain model here. Okay. And once upon a time, we had separate analysis and models for with slightly higher level notation from the sort of notation you use in UML for classes and stuff, but no one really does that anymore. So let's return to this idea of fracture plane we got from team topologies earlier. So a fracture plane is a natural seam in the software system that allows the system to be split easily into two or more parts. It's usually best to try and align software boundaries with the different business domain areas. So the business domain you can think of as there is a generic domain and then there are subdomains. And how far deeply down you go depends on the nature of your problem. So nowadays, like Menulog, we tend to do what we call hyperlocal delivery. So it's not just food anymore, it tends to also be anything you want nearby. And what we really have is three key areas, right? Because we're basically the customer, what we call partners, so basically the stores we deal with, and couriers. So those are three key domains that you can think of basically in a multi-sided network, right? And we effectively also, when you think about it, can think, well, maybe there's also some other things we tend to think about. We think about a domain which is effectively moving work between those three. So you effectively order something and I have to decide, is there work for a courier? Is there work for a partner? What does that mean, right? And money, we move money around between those people. So you get some money, we pay couriers, we pay partners, we take a cut. So that would be breaking it down to 5 subdomains. Now in actuality, we break it down more, right? So in that customer, think about separating search from shopping baskets, etc. But as you can see, we're just breaking down that model into pieces. Now you can just do that by talking to people who are subject matter experts, right? Talk to people who understand the problem space that you're dealing with and say to them, well, what do we need to do? What are we automating, right? How does it work? What is the business that we're dealing with here? You can use domain storytelling. So domain storytelling will show you a little abstract diagram of it. It has a mechanism for you to say, okay, maybe some parts of the diagram we've just drawn, we could identify them as subdomains. If you're more old school, you can effectively, if you're a Six Sigma people, you can use a technique called value stream mapping. So I haven't got time to go into value stream mapping overall, but essentially you take a process. So some of you stayed at hotels. There's a process at hotels called the guest life cycle, which is effectively all about things like search for a hotel, book the hotel, turn up and give my name at reception, get my key printed, housekeeping services in my room and I check out and get a bill. And you can work them backwards. You can say, where do all the items on the bill come from, etc. And you think about operational flows, which are basically me staying in the hotel, and environmental flows, which are things like them stocking the minibar, them basically providing towels every day, that kind of, etc. So different ways to do it, but the key often, one of the best ways to do it is to essentially really often think about those domains aligning to key processes that your business runs. Processes tend to be stable over time. Okay. So in domain storytelling, for example, we could say, we could say there's a given heuristics which say you can find the subdomains. So one may be an actor that's doing a whole lot of work with work objects on their own. That set of work objects it's working with is probably a domain. One way information flow. So in other words, what that means is I go and do a whole lot of stuff as an actor, and then I basically create a work object, and then you go and do a whole lot of stuff. And that tends to be that handover effectively is between two domains. Different triggers means, hey, I'm triggered by a customer turning up at the front desk of the hotel, or I'm triggered by the minibar being empty, right? Very different things. Activity supporting something not in the picture. Yeah, so effectively, sometimes we get activities which relate to things we haven't actually modeled, and they tend to be off-screen kind of domains. Differences in language, the classic domain-driven design one, you may refer to a concept like a room. It might be a generic term, but actually we mean quite different things by it because of our context. We think about those things differently. Maintenance thinks about a room differently to booking, right? Yeah. So I can go and draw some boundaries, right? And here's one that's just I've drawn up quickly. You don't tend to include the actor. Now to merge slightly into that one, but generally it's the work objects, not the actor, that are involved in a given domain. Actors sit outside of domain boundaries. All right. One thing to remember, right? Whichever model you choose to try and find your subdomains, and it's an art, not a science, right? So one of the things to remember is that your domains change as the business changes, and that's constant. Right, particularly in the modern era, businesses pivot, change, swap what they're doing on a really rapid basis. Because that's not static, that means your domains are not going to be static. If your domains are not going to be static, that means you're going to have change, right? And when we think about it, processes, we said, are more stable. So a business process like check-in is reasonably stable. Activities and tasks like verify identity, print key, are likely to be much less stable. And you can see evidence of that, in particularly the guest lifecycle, right? So if I visit a Hilton because I've got their app, I don't even need to go to the front desk. I can check in with the app, and it's also my room key. The process of check-in is the same, but the activities and tasks may well have changed, or you may get duplications and additions of new one. So one tip is to always focus on processes, but it's always going to require some constant maintenance. Okay, and we need to keep thinking about how that logical model changes and working with it. All right, it'll become important in that particular conversation in a second. All right. So the development architecture focuses on the actual software module organization and the software development environment. The software is packaged into small chunks, programming libraries are subsystems that can be developed by one or a small number of developers. So if we think about what we assumed microservices were, we can see this is the point where we are effectively defining our microservices. Okay. So remember, from Jordan and Constantine, the parts of the original problem must be solvable separately. Okay. So I think about this point, I tend to call it the Goldilocks zone, right? That is what we are aiming for. We are trying to land in that space where we trade off between the size of our actual the service we're creating and the number of interdependencies we have. Okay. Some things are granularity, integrators, and disintegrators. This comes from Software Architecture: The Hard Parts by Neil Ford and others. So the things that integrate us, that would mean we'd want to be part of the same service. ACID transactions, you don't want to split ACID transactions across boundaries, right? So that includes things like, for example, when you add an item to the cart for us, right? We price everything, tell you the charges, etc. We need to do that for the current state of the cart, not the cart plus the 2 items you're just trying to add in as well, right? So it's an ACID transaction there. Shared code, in other words, basically we have some piece of domain logic that we don't want to replicate across multiple services. We just want it to have it in one place has that knowledge of how to do that work. And shared data. If I have to ship around massive blobs of data between each service as I'm calling it, the question is really, shouldn't I actually be moving the work to where the data is? So those are integrators. Disintegrators is service scope too large. In other words, I can't get my head around this problem, it's too big. Distribution of code changes. So a whole load of different stakeholders need change here. And that's going to cause us a problem because effectively we're going to get blocked by a backlog, saturation, or a release train. And continuous change for new problems. In other words, basically, new things occur, but I'm always changing this one place. Okay. So a fracture plane, again, is a natural seam in the software system that allows a system to be split each into 2 or more parts. It's usually best to try and align software boundaries where there are different business domain areas. Fracture plane, business domain, bounded context. Now I think that's a slight misunderstanding of bounded context we're going to explain. So your domain is a logical view of the world and your bounded context is a development view of the world. And your bounded context just refers to people, code, processes, etc. that all share a common language around something. So it limits something like the definition of a word room in the hotel trade, right? We are referring to room as something that's bookable by and has a certain capacity by a customer. I am referring to room as something that has, I don't know, a shower and can go wrong and break or whatever in maintenance, right? So you may have different properties and things that you care about. So bounded contexts say, what is the limits under which effectively that definition holds true? Now, in an ideal world, well, after you've done your logical model, you go, excellent, and now each of one of my domains would be a bounded context, but that doesn't really always happen. Things drift. So there's a whole part of domain-driven design which it talks about called context mapping, which is about addressing that drift. But the other thing that happens is maybe that isn't the right choice. Sometimes it's okay to have multiple domains in one bounded context, and sometimes it's okay to split a bounded context across domains. Right. So the first thing you should always consider is whether you should be using a monolith, right? So you basically think about, well, okay, I've got multiple domains, multiple components, one service. Those components are effectively those domain boundaries. So I just think I can segregate into a module or a more popular component because it's probably replaceable inside my service and have that represent that individual subdomain, right? It may be because you're not very big, right? You're a small team or you're too mature. In other words, you don't want to deal with all those, you're not tall enough to ride in the microservices roller coaster yet, right? So it's a monolith, right? Use components within the monolith for your domain boundaries. The system has a single CI boundary, so you build and release it all as one. Typically, you don't want more than about 35 devs. It begins to break down at that point. You'll probably want a single repo to host it in. If you are unsure about what the bounded contexts are, if you're unsure how would you break up this domain into pieces, it may be better to start here. Because refactoring the domain boundaries is much easier when they're not process boundaries. So if you go, I don't really understand this domain, I don't understand what's going on, building microservices is a mistake because you don't understand the domain boundaries well enough to make that prediction yet, right? Start with a monolith, figure out what those boundaries are, and then break it up. Okay. So the next simple model is where effectively you do have a classic alignment where you essentially say, hey, this subdomain is going to become a bounded context. It's a solvable problem by a kind of up to 2 pizza team. This is my classic microservice. This is exactly what microservices were built to support, right? So the code for the subdomain fits neatly in your head. Forces for change or replacement are cohesive. In other words, I'm probably going to get one set of reasons for this to change. It's the shopping basket. So it's going to have all the change around shopping basket stuff, right? ACID requirements can be satisfied within the service boundary. In other words, that boundary is not going to split an ACID transaction. And you have sufficient scale to justify componentization via service. So in other words, we're big enough and bad enough to do microservices. Okay. And so that is classic microservices, and that's where you should do microservices. Sometimes you get a complex domain, right? You have a large domain, and you still think, okay, I'd like to put that in some kind of service boundary, but actually within that service, I want multiple components. So typically this is caused by the domain is more complicated than you would like. It's not code that fits in your head, it's code that probably fits in the head of 2 or 3 teams, right? So can you actually say, all right, we could split this given domain up into 2 or 3 different bounded contexts. They may actually be activities or tasks within that process, right? Prefer activities to tasks. You might be able to break that up separately. You might be able to say, okay, each one of those activities is now going to become a new bounded context, aligned with the team and its own microservice. But you might find you don't want to do that because you'll violate some of the other rules. ACID transactions, splitting across boundaries, shared code, shared data structures, right? We'll explain your option here if basically this doesn't work out for you in just a second. So if it's not independently solvable, which is our criteria, I probably need a single bounded context effectively for that, all right? Okay. The other model that is a problem space and not your classic microservices is you have multiple small domains. These things are tiny, and it feels like a lot of overhead to give each one its own build scripts, its own telemetry, and your team is going to end up owning a whole load of these because, frankly, it's too small for a team to essentially just focus on that one piece of work. So you're going to have to give them a load of them, all right? So code for each domain is much smaller than your head. It may need to be combined to other domains in one bounded context. So you may need to think about the fact of saying, okay, well, maybe actually we could put all these things together in a single bounded context, right? And what you're looking for is domains that, even though you feel that this is a separate subdomain, it's not truly independent. You could model it that way, but also you can model it as a concern of a larger thing, right? The behaviors tend to be about the same work item. Quite often we've got tight chain of communication. So typically what you'll see is 2 things that you thought of as being separate, but they just talk to each other. They don't talk to anything else, right? And that typically means you've got distribution, but you've not really got value. And often the communication is very tight, and if this side changes how it works, the other side needs to change, right? And typically you may also find that you are distributing an ACID transaction across these multiple tiny domains, right? So you've got multiple domains which ought to have at one point implied multiple different bounded contexts and multiple services, but there's going to be a lot of overhead to deal with that. Okay. So the answer to both of these problems is to use what Cindy Streeterhan calls a macro service. So a macroservice basically is a service that has multiple components within it. It's not a monolith because it's not your entire system in one single place, but it's bigger than a microservice, and it says I've got modules inside, right? You'd probably top out on these. We think about basically 5 pizza rule, about 20 devs, right? So don't build them up to about 35. It's going to get quite complex and large. But it's okay to have about 20 devs working on one of these. You may typically find that you may have sub-teams that own given modules inside the macro service, but they effectively tend to report to the same manager, and they tend to effectively be able to therefore coordinate easily around releases, and they may even have just a single product manager who works with them. You've broken the problem up because of some complexity. They may need a mono repo, right? Because they may want to need to change code that basically is in common to all of them. There's a really nice, I haven't got time to go into it, pattern called the Hive. A bit hard to search for because the Hive is also a data sort of data engineering principle as well. But really, what that is this idea of taking multiple ports and adapters architectures and plugging them together. It's really interesting. What it's effectively saying is you get the isolation of the ports and adapters architecture, and you just treat the other module as something that lies beyond an adapter, and therefore they're very isolated from each other. So it's a really neat way of doing this. So dependent management is easier. You've got fewer services or repos. You have better observability of debugging of the problem space because it's typically a single problem space that you actually tend to find yourself dealing with. So these macro services help balance the tendency to break things up unnecessarily. We identified earlier on that basically things are going to keep changing in our development model, right? So this is the problem, right? That refactoring is more difficult. So this is why you don't want to move too early on it. Is there any way of fixing that? Now I'm not going to go into it, I don't have time to go into it in this talk, but those of you not come across Barry O'Reilly's work on residuality theory. Residuality theory is an interesting way of stressing your system in order to effectively find what states it may move into with change. And that may be a more useful way of predicting what boundaries you should have to cope with future change to the system, because those boundaries are difficult to basically predict. All right, let's speed up a little bit for time, because I'm close. Process models. All right, so process is a grouping of tasks that perform the executable unit. Process represent the level at which the process architecture can be tactically controlled. So basically, it's executable things that you can run, right? How do you divide this stuff up into executable units? So the naive view, right, is that every microservice is a process, and that's just wrong, right? So modern applications seek to be application-centric, not infrastructure-centric. What do I mean by that? We mean that basically developers write some code and they say, I depend on all these things, and these things should typically be services that I can configure. So that is the 12-factor apps model, and is essentially what gets built into things like Kubernetes, right? So essentially what you want to do is build apps that effectively talk to external concerns. And you effectively have this idea of also interoperability. So are you going to be asynchronous or synchronous, right? We're not going to get into those choices today, but that's also part of this model. All right. Now, a key idea basically from James Lewis and Martin Fowler always was a service may consist of multiple processes. So what do you need? So the useful idea to take is from 12-factor apps. So the idea is that you have different process types, and process types depend upon what work they're doing. So if I'm basically receiving HTTP requests, that's a different workload to I am reading things off a Kafka topic. And those different process types have different scaling needs. So for every process type that you effectively have a process in your microservice. And the set of process types we call the process formation. And for any given process type, I may need to scale multiple instances of that process type, right? So typically, we tend to see a whole lot of model where we have a web process and a worker process. And the worker process is effectively reading from a queue or a stream, and the web process is effectively responding to HTTP. And they scale very differently. I scale based on the number of requests I'm receiving effectively over HTTP. I scale on the latency of the queue. If it's Kafka, I'm scaling across a number of partitions, for example. I may even need multiple workers for different topics. Say, for example, right, I may have a really busy Kafka topic and one that's basically very quiet. That might require me to have different process types. So your processes are a function of how you scale. They're nothing to do with your basically development boundary of how you break things up cognitively. So don't get the two ideas confused. Okay. Again, we have some integrators and disintegrators, which may affect basically how we think about processes. ACID transactions and shared code tend to force you into a single process. Scalability and throughput and fault tolerance tend to split you apart. Okay. So, a microservice equals a 12-factor app. A given microservice, therefore, a macroservice could be multiple apps or a kind of microkernel architecture. You can do them either way. Microkernel is a pretty useful architecture, or the Hive architecture we were discussing earlier. And so either these apps or microkernels consist of multiple process types. Right? So that model of a container equals a microservice is really wrong. Now, and then we get into the final bit, which is physical. And the physical bit is just how am I deploying my processes. All right. All right. Sorry, I don't have any time for QA. I must have waffled earlier in the talk too much. But you can come and catch me during pack up. All right. Thanks so much.